you may not have control over. All going well, and God willing, you should not have any disruptions till your MMD exams get over now. Let's try to connect in time so that we can utilize our time to the fullest and we are able to finish not only as per schedule, maybe a day or two ahead of schedule if everything goes well. Otherwise, at least we should stick to the schedule and release you by 27th, 28th of this month, because first is your naval arc exam beta. Some of you may be, as far as traveling is concerned, you can travel during the gap period beta, and you can connect from anywhere. That's the advantage of online stuff. So yesterday I had shared with you the moment of inertia formulae for regular geometric shapes so that you don't waste time in taking down in the class. It was just to save on your time, and so that in the class, instead of jotting down, you try to understand what is being explained. I have also shared a set of questions, which is the agenda for today. So the agenda for today is to learn the formula, or understand rather. Learning would automatically happen as you go through the process. So to understand the moment of inertia formulae for regular geometric shapes that are of relevance to us, not all regular geometric shapes, the ones that are relevant to us. And secondly, do one of its application, that is how this moment of inertia is relevant to us in calculating what is called as center of pressure for regular geometric shapes. So that is our agenda for today. Tomorrow we'll take it forward. So that is the agenda for today, and hopefully in another 2.5 hours from now, at the end of this class, hopefully all of you should be comfortable with the stuff. My only request to every one of you is that please try to use the calculator that you intend taking for exam. Try to solve with the class. Okay. When the class is on, you keep yourself muted. Unmute yourself whenever you want to clarify a doubt. Once you have posed your question, please mute yourself. But in between, I'll be checking with you, understood or not. That is just to ensure that we remain connected. It should not happen that either there's a glitch at your end or my end, and I'm just talking and nobody's getting me. So whenever I check, at least somebody from the class should acknowledge that you have understood. So that is besides affirmation of the fact that you have understood, it's also a confirmation of the connect being there between the two sides. So that is the reason it will be. But as soon as your response ends, my request would be that you mute yourself. Okay. Guys, do not hesitate to ask for the doubts. I'll be asking everybody, are you done up to this calculation? If you are not done, let me know. Okay. Sometimes you may start having problems. Your screen may get frozen. Sometimes your audio may give problem. If you have to, the best way is, if your screen has got frozen, is to log out and log in again. But what you should try and do is, before you log out, you shout out your name, saying that you're having a problem, you're logging out, so that if it's for 10-15 seconds, I can wait till you're back into the meeting. Okay. So if we follow this simple protocol, it will make learning really a pleasure, and it will definitely be more fruitful than just going on ad hoc basis, not knowing what we have to do and how do we get our doubts sorted. So any questions on what I said, guys? Is that okay what I said? Do you agree with that and agree to cooperate in that particular aspect?
Yes, yes, sir.
Yes, sir.
Yeah.
Yes.
So let's get going, beta. The first topic is the moment of inertia and its application in ship stability. Now, all of you have been using the first moment. First moment, all of you have used. When have you used first moment, guys? You have used first moment in calculating kg, LCG. That was the first moment of weight or mass. You have also used the first moment of area and volume in your Simpson's rules. If you remember, in your Simpson's rules, you have used this uh, first moment where you type A1 into D1. D1 was the liver. So what was important in the first moment? If you don't understand what I'm saying, those who have been with me would understand what I'm saying. If you've not been with me and if there's a gap, please let me know. Whenever you say first moment, be it of area, be it of volume, be it of mass, be it of weight, it is the physical quantity, that is area, volume, weight, or mass, multiplied by liver. Now, what is the liver? Liver is the distance of the centroid of that physical quantity from the reference axis. That means moment of inertia by itself is an incomplete statement. When you, sorry, the first moment, if I say moment of this area, now that is also incomplete. Why? Because unless you know about which axis, this information is not going to take us anywhere. So when you talk of first moment, it's important. Moment of what is first question you'll ask. And second you'll ask yourself is which axis? Why? Because the liver shall be with respect to the axis. And I've just told you what is liver. Liver is the distance of the geometric center or the centroid of that physical quantity from the axis in use. Exactly the way you have the first moment, we have the moment of inertia in which I must know whose moment of inertia are we talking about. Are we talking of moment of inertia of mass? Are we talking of moment of inertia of area? Whatever figure we are talking the moment of inertia of, we must know MOI of what. Second, again, the axis is as important as it was in the first moment. So again, you'll say moment of inertia of what and about which axis. Now, unfortunately, moment of inertia is not straight connected to the liver the way first moment was connected. It is connected to radius of gyration. Okay. In basically in moment of inertia has the same role in the rotational motion as you have the mass in the linear motion. Straight line motion, whatever the role mass has to play, same is the role of moment of inertia of a body in rotational motion. So they are basically counterparts of each other, one in straight line motion, rectilinear motion, other in the rotational motion. Okay, so basically we have studied about this moment of inertia in schools also. In schools, we have studied this moment of inertia as mk square, where k was the radius of gyration, if you remember. In all our working, we will represent the moment of inertia mostly by capital I and sometimes even by small I. So whether it is capital I or small I, both will represent moment of inertia. So don't get confused. But this was the moment of inertia of mass. In our topic today, we are not going to talk about moment of inertia of mass. We are going to talk about moment of inertia of area. So as far as in our context it is concerned, as far as our context is concerned, we are going to talk about moment of inertia of area, and which is nothing else the second moment of area. First moment I just explained to you a while back. Second moment of area is referred to as moment of inertia as far as our topic is concerned. So you should not have confusion. In school, I studied mk square. Why now m is missing? That was moment of inertia of mass. This is moment of inertia of area. So that should put your doubt to rest. Every time we talk of moment of inertia, please ask yourself two questions. Moment of inertia of which area are you talking about? Every time we can't write everything, but I must keep talking to myself and keep asking these questions. Moment of inertia of which area? Because unless I know which area I'm talking about, I can't talk about moment of inertia, obviously. Second, I must know is about which axis. If I do not know either of these two things, or I do not know any one of these two things, or both of these two things, I cannot be getting the moment of inertia. I cannot be answering any question related to moment of inertia. Thus, moment of inertia will depend upon the area in question, the choice of the axis, and with respect to the axis, how is the area distributed? Okay, you may have this area, let us say this area is 10 square meters. This area is also 10 square meters, but one is a square, other is a rectangle. Or let me put this, okay, let us say this is the axis about which I want the moment of inertia, y, for area, which is represented by the red one. Now I change the shape of the area and I make it a rectangle, retaining the area to be 10 square meters. So now I change the area like this. Axis is same, amount of area is same, but the distribution of the area in the blue one is different from the distribution of the area in the red one about y. Therefore, in both these cases, moment of inertia shall be different. And that is what I mean by the third point. Is the third point clear, guys? Distribution of area about the axis. Clear, beta?
Yes, sir.
Yes, sir.
Any questions
Yes, sir.
until now, beta? If anybody has any doubts to clarify.
सर वो gyration लिखा था ना आपने about gyration क्या होता है?
उसको छोड़ दो, हमारे जरूरत का नहीं है, बट रेडियस ऑफ जायरेशन इज द रूट मीन स्क्वायर ऑफ रेडियाई ऑफ ऑल द constituting particles.
नहीं सर, थोड़ा simple
I can explain, but there's no need to go into it. It's basically radius. Agar if a body is made of, let us say, n particles, and each particle will have its distance, then they are basically point particles, right? They will have their distances from the reference axis. They will be r1, r2, and so on. Radius of gyration will be equal to square root of r1 square plus r2 square up to rn square divided by n. So it is the root mean square of all these radii. I'll not take you into that detail. It's not required for us. Just to tell you, radius of gyration is not the distance of the centroid from the liver, from the axis. So that should be not in your mind. Is that clear, beta?
Okay, sir.
Yeah, so that is good enough. I can prove this to you, but there's no point. We don't have to spend time on that. As long as this expression gives you an idea that radius of gyration is not same as the distance of the geometric center from the liver, right? Okay. Now we come to the regular geometric shape, these formulae. You will automatically pick them up as you use them in the question. Whatever PDF I sent you yesterday, you are free to refer to it while you are doing the questions. And if you don't learn them by the end of the assignment, please spend 15 minutes to learn the formula if the need arises. We need to recall the use of formulae for moment of inertia of regular geometric shapes, which we did in school. Some of them we proved in the school, actually, we derived in the school. The regular geometric shapes that we are going to use are rectangle, triangle, circle, semicircle, and quadrant, that is 1/4 of a circle. These are the shapes we are going to use, guys, in our working. And these are the formulae I have sent you yesterday, actually. Let's start with the rectangle. We know what a rectangle is. We don't have to spend time on that. Let us say the length of the rectangle is capital L. The breadth of the rectangle is capital B. First, we must know the formula for the area. We know the area of a rectangle is L into B. Then second thing is we identify its geometric center, centroid. Centroid will be the intersection of the diagonals, guys. Centroid will be the intersection of diagonals. This is one diagonal, this is the other diagonal, and where the two diagonals intersect, this is the geometric center of this rectangle. Now we will learn some standard formulae. When I say standard formulae, please be careful to remember which shape, which axis. There are two standard formulae which you need to learn as far as rectangle is concerned for moment of inertia. One is about this axis. I have called it as x-axis. You can name it whatever you want. I have named it x-axis. So what is so special about this axis? This axis is passing through G, the geometric center, and is parallel to side L. How do you describe x-axis? X-axis is an axis passes through the geometric center of the A rectangle and is parallel to the side L. The moment of inertia about x-axis, which I represent as I-x-axis, is given by this formula LB cubed by 12. Length into cube of the breadth divided by 12. See what I have written here. This represents the axis about which you're talking about, the moment of inertia. Another axis we need to learn about is this one, YY. Now, IYY will be BL cubed by 12. How do you remember which side to cube? You cube the side which is cut by the axis. Here B was cut by the axis, so B cube. YY is cutting L, so it is L cube. Now, what is so special about X and YY? Both are passing through the geometric center. If they don't pass through the geometric center, these formulas will not be valid. So both of them are passing through the geometric center and they are parallel to one of the sides. X is parallel to length, YY is parallel to breadth, and you cube the side whichever is being cut by the axis. Is that clear, beta? This will help you in remembering which one to cube. Is that clear, guys?
Yes, sir.
Yes, sir. Okay. Next, we go to triangle. Now, before I start talking of triangle, I want to just take a minute of yours and explain something which people usually make mistake about. Guys, the triangle has three sides. Okay. And we know the area of the triangle is half base into height. Now, please understand that any of these three sides could be acting as a base. Then which height are we talking about? We are talking about the height which is corresponding to the base in question. We are talking of the height which is corresponding to the base in question. For example, if somebody says, I am taking this as the base, B1 as the base, then we go to the opposite vertex. Opposite vertex is A. We can draw a parallel side through it, parallel to base. And the perpendicular distance between these two parallel sides is the height 1. H1 corresponds to base 1. In another scenario, I may be required to use another side as the base. Suppose I need to use this as the base, B2. Which is the vertex opposite to B2? Capital B. What do? Through B, I draw a line parallel to base AC. And then I drop a perpendicular wherever you can drop. You can measure here also. You can measure here also. It doesn't make a difference. This is H2. So height 2 corresponds. So if you are calculating area, if you are taking B1, you will multiply by H1. If you are taking B2, you will multiply by H2. And if you're taking the third side as the base, you could be needing any one of them to be taken. So please don't get confused when we start solving questions. If you want to take this as the base, then the distance, perpendicular distance from here, this is height 3. So is the concept of base and height of a triangle clear to everybody, or anybody has any question on that, beta?
Clear, sir.
Okay, so I'll clear this and we go to triangle. Okay, this is the triangle we are talking about. Area of the triangle is half base into height. Now here I have taken B as the base and the height I'm taking as capital D. So it will be half base into the height D. Okay. Caution. Height being corresponding to the side chosen as the base, which I just explained you a while back. Please make sure that you take appropriate height, appropriate to the base in question. So you cannot just mix it up. Geometric center of a triangle is the intersection of its medians. What is a median? Median is a straight line joining the one vertex to the midpoint of the opposite side. That means if you take A as the vertex, opposite side is this one, you take its midpoint, you join it with a straight line, that's a median. Okay, so you draw the three medians. This is one median, this is the second median, and this is the third median. Where the medians intersect, that point is the geometric center of the triangle. And also, the distance of the geometric center of the triangle is 1/3 of the height from the base and 2/3 of the height from the vertex. So this will be 1 by 3D and this will be 2 by 3D. Please don't get confused and reverse. The distance of the centroid of a triangle is 1/3 of the height from the base and 2/3 of the height from the vertex. Is that clear?
Yes, sir.
Clear,
Yes,
guys?
sir.
Okay.
Yes, sir.
If the base was different, then it will be 1/3 of the corresponding height and 2/3 of the corresponding height. So you have to be careful between base and height. Okay. Now, in this case, we will learn two formulae. Why now you'll say, sir, why you're learning two formulae for a triangle? Why not only one? Because our questions use them. If you learn one formula extra, that will help us in saving time when we calculate do the questions. So the axis that, so one, we need to know about this. Guys, what is so special about the axis that I have drawn, XX? It is passing through G and parallel to base B. XX is a axis passing through the centroid and parallel to base B. And the formula for moment of inertia about this is BD cube upon 36. B is the base, D is the height. BD cube upon 36 is the formula. Second formula, which we can manage with one also by use of theorem of parallel axis, but learn it better it is, good buddy. If you take this axis YY, what is it? It is the axis coinciding with the base. Axis coinciding with the base. The moment of inertia calculated by theorem of parallel axis is BD cube upon 12. BD cube upon 12. So if this formula you learn, this will help us in some of the questions when we apply it. But be careful, it is coinciding with the base. So height is corresponding to the base with which you have coincided the axis. Okay. Any questions on triangle, beta? All okay about triangle now?
Yes, sir.
Okay.
Yes, sir.
And while I have finished this, just have a look at the PDF that I sent. Then you're able to, so that there you can fix these axes and then you can, when you refer to it, it should be clear to you. Okay. The third we come to is a circle. We all know what a circle is. It has a circumference, it has a diameter, it has a radius, and we know where is the center of the circle. Center of the this is the diameter of the circle. Half of it is the radius. All of you know it. And area is pi r square. In stability, when we take pi, we'll take it as 22/7. We'll not take it as 3.1428. We'll take it as 22/7. Where is the geometric center of a circle? Where all the diagonals intersect. If I draw one more diagonal or another diagonal slanting one also, they will all meet at this point. That is the center of the circle G, geometric center, right? Now, we learn about moment of inertia of a triangle about this axis, x-axis. You see, about x-axis, what happens? One semicircle is on one side, another semicircle is on the other side. When you take y, again, the area distribution is similar. You have one semicircle on one side of y, another semicircle on the other side. If I take any other diameter for that matter, suppose I take this diameter zz. Even for zz, you see, on one side of zz, you have this area, which is a semicircle. On the other side of zz, you have another semicircle. So whether it is xx, yy, or zz, the distribution of the area does not change. Compare it with the triangle a while back. When you took about this one xx, the distribution was some area was above it, some was below it. When you took yy, everything was on one side of yy. So distribution changed, the formula changed. But between xx, yy, and zz, the distribution is not changing. Therefore, it will all be pi d 4/64. If you put d as 2r, it will reduce to pi r 4/4. If both are same, it doesn't matter. So basically, this will be the formula about any diameter. It doesn't make a difference which diameter are you talking about. So is the formula for circle clear now? But any diameter of the circle, the formula will be same. Clear? Clear, guys?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Then we come to semicircle. We have just studied about this full circle beta just now. And we know what was its area, we know where the geometric center was, and everything. But now, if I remove one half of it, what am I left with? I am now left with semicircle. Obviously, the geometric center will not be on the diameter now. But but all of you would agree that the geometric center would be on this radius, yes or no, beta? Why? Because you have identical areas on each side of it, yes or no? Correct? Do you agree the geometric center of this semicircle will be on this red line, yes or no?
Yes, sir.
This is the radius perpendicular to the diameter of the semicircle, correct? Okay. Area of this will be half of area of a circle. What was the area of a circle? Pi r square. This will become pi r square by 2. Where will be the centroid of it? It will be on a radius perpendicular to the given diameter. Now, where will be the geometric center now? Obviously, I'm sure you'll agree that on this red line, the geometric circle will be closer to the diameter than the circumference. Why? Because on top, the width is reducing with the curvature. Because of the curve, the width of the area is reducing. The geometric center of this semicircle would be somewhere here. And this distance is what is given as 4r by 3 pi. That is the distance of the centroid of the semicircle from the diameter. Distance of the centroid of the semicircle from the diameter. You'll have to learn this formula, 4r by 3 pi. Let me clear my diagram. this distance is 4r by 3 pi. Okay, so if you know the radius, you can get this distance. Now, which axis are we going to study the moment of inertia? Again, we'll study about two axes to facilitate simple calculation. One axis every time will be passing through the geometric center, no, undoubtedly. So one would be through the geometric center, and the second one would be this one, YY. Guys, recall the circle a while back. This was the circle. This was the diameter of the circle. And if I take the axis about the diameter, YY, then for the full circle, it was pi d4 upon 64 or pi r4 upon 4. Am I clear, beta? This was for the full circle, correct? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
What now? I'm keeping the axis same, YY. What I'm doing is I'm removing this half of the area. If I remove half the area, the moment and axis remains same, the distribution of the other half has remained unchanged. So this moment of inertia will become half of it. That's how you can remember it. This will become pi d4 upon 128, double of 64. And this will become pi r4 upon 8. So about YY, it will be straight half of what it was for the circle. Pi d4, sorry, say upon 120, yeah, 120, pi d4 upon 128 and pi r4 upon 8. Guys, will you be able to remember this now through this method? Because the axis has remained unchanged, only half the area has disappeared. So the moment of inertia will just become half. Exactly. Correct, beta? So you don't have to learn this formula. As long as you learn for the circle and you can make it half, your job is done. You don't have to remember all the formulas, otherwise there will be confusion.
Yes, sir.
No, yeah, so for YY, it is linked to circle. Why? Because YY was the axis for the circle also. But we have also need to learn about an axis passing through G and parallel to the diameter. This one, XX. What is XX? It's a axis passing through the centroid of this semicircle and parallel to diameter. And the formula for this is given in fractions, but I have simplified it was given in a equation form, pi up 8, pi up or 9 or something, but I have simplified it for you. And the fraction that you get is very easy to remember. It's 0.11003 r raised to power 4. 0.11003 r raised to power 4. So you remember this expression about xx, it will be 0.11003 r raised to power 4. That will be the moment of inertia of the semicircle about an axis passing through its centroid and parallel to the diameter. So guys, is the identification of axis for semicircle clear now? Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now we go to the last set of the formulae, that is the quadrant. We started with the circle. We lost half of it. It became semicircle. Then we lose. Here was the geometric center of the semicircle. Now tell me before I go further. Tell me, guys, if this was the geometric center of the semicircle, then what do you think of area A1 and A2? Do you agree that the geometric center of A1 and A2 would be on this line somewhere? Then only the combined geometric center would come here. Yes or no, beta? Yes or no?
Yes.
The geometric center of A1 and A2, they have to be on this line, let us say AB, for the geometric center of the combined area to be at G on this line. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Exactly the same way, if I take this semicircle, Which semicircle? I take this semicircle now. Where will be the geometric center of this red semicircle that I have drawn? It will be here. Yes or no, beta? Correct?
Yes, sir.
This will be the geometric center of the red semicircle. At what distance? 4r by 3 pi. This is 4r by 3 pi. This is also 4r by 3 pi. We just learned for semicircle. Now, why will the red semicircle have its geometric center at G1? Red semicircle comprises of area A2 and A3. That means A2 and A3 would have their centers on this line. Then their geometric centers on this line. Therefore, A2 plus A3 will have the geometric center at G1, like we said about G. So what do you see? A2 has its geometric center on this line. A2 also has its geometric center on this line. So where does the geometric center of A2 lie? This is the geometric center of the quadrant. Yes or no, beta? Correct?
Yes,
Correct,
sir.
bacho? And it will be at a distance of 4r by 3 pi from each of the radii. So anyway, don't worry. You can learn it if there's a problem. And if you can understand, it will simplify the things. That's all. So we started with a circle. We had this semicircle. We had the G here. Then we had this formula. All we had. Now we knock off another half. So what will be the area of the quadrant? It will be 1/4 of a circle. What was for the circle? Pi r square. What will be the area for the quadrant? Pi r square by 4. Where will be the centroid of this quadrant? I just explained to you. The geometric center shall be at the same distance from each radii, that is 4r by 3 pi. That means the geometric center would be here. I just explained to you why it will be here. Now, which are the axes we are going to take the moment of inertia about? See, whether I take about the moment of inertia about this axis, the radius ZZ, or I take about AA, I'm sure, firstly tell me, do you agree moment of inertia of this quadrant about AA would be same as moment of inertia about ZZ? Is that going to be yes or no? Yes or no? Because area is distributed
Yes,
the
sir.
same way about both.
Yes,
Yes or
sir.
no? Beta?
Same.
Yes, sir.
Same. Correct.
It's going
So
to be
firstly,
same.
you agree they are equal. Okay, fantastic. Now, ZZ is the center diameter of the full circle. What is IZZ of the circle? IZZ of the circle was pi d4 upon 64 or pi r4 upon 4. I have removed this half. I have removed this. What have I kept? I have kept the axis ZZ only, but I have made the area 1/4. So what will happen? These will also become 1/4. What will it be? Pi d4 upon 6, 1, 256 or pi r4 upon 16. Is that clear, beta? Understood? So it will become 1/4 of that of a circle about the diameter. So you remember or it will become half of what was for the semicircle, whichever way you want to do it. So it will just become half of the semicircle or 1/4 of a full circle, whatever you want to take. I'll take you through this and then I'll ask you if there's any doubt on it. Now, is pi d4 upon 256 or pi r4 upon 16? You know how it has come. You don't have to mug it up. Yes or no, beta? Understood?
Yes, sir.
Yes, sir.
This is 1/4 of what was for the full circle. Why? Because the axis is the same. We have retained the same axis. But we will also have to learn about an axis passing through G. Now that can be either this axis, XX, or that can be YY. See, what the way area is distributed about XX, same way it is distributed about YY. So firstly, moment of inertia about XX and YY shall be same. And this is equal to, you don't have to mug up another formula. For semicircle, about this axis, it was 0.11003 r raised to power 4. Now I have removed half the area. It will become half of it. Don't remember another fraction. Write like this only. 0.11003 by 2 r raised to power 4. So don't have to create one more fraction to remember. Just make half of what it was for the semicircle. Is that clear, beta? Let me clean the slide and show it to you. And then, since this is the last of the regular geometric shapes, I'll check with you if any one of you needs any clarification on any of the things that have been said. Now tell me, guys, is that good?
Yes, sir.
You have all this with you for referencing. There are two parts of learning. One is correct application. Second is remembering the formula. So there'll be two parts of to the learning. Guys, any questions? I will be silent for 15 seconds to hear from you. If you don't ask any questions over next 15 seconds, I'll continue.
Sir, how does this pi d4 by 256 become pi r4 by 16?
Beta, one second. For the full circle, what was it? Pi d4 upon 64 or pi r4 upon 4, right? What is the diameter of a circle equal to? It is equal to twice the radius. So it becomes 2r raised to power 4 upon 64. Correct, beta? Yes or no?
Yes, sir.
So what will this become? 2 raised to power 4 will become 16. So it will become 16 pi r raised to power 4 upon 64. And this will become pi r4 upon 4. Yes
Okay.
or no?
Yeah, got it, sir. Got it. Got it. Thank you.
Yeah. Okay. Okay, guys, before I close the slide, we have to learn the theorem of parallel axis, which will be extensively used in our questions and applications also. Okay. Now, suppose there is any area. I'm just making rectangle for the sake of simple drawing. Otherwise, it can be any shape, irregular, regular, whatever it is. Okay. Let us say we have this rectangle or whatever it is. Okay. Suppose somebody says, I want the moment of inertia of this rectangle about this axis. Now, this does not have to be always outside the shape. It can be inside the shape also. The Z can be here also, guys. So don't, I'm keeping it out so that the explanation becomes clear. Now, what is required is IZZ. So what we can explore is, we identify the geometric center of the area, which in this case will be here. To the geometric center, we draw an axis parallel to the given axis. That is, I draw one parallel to ZZ. Let's say I call it as GG, passing through the geometric center. Then the perpendicular distance between these two parallel lines, we call it as D. And this area in question, we call it as A. Now, as per theorem of parallel axis of moment of inertia, IZZ will be equal to IGG plus A into D square. This is the expression for theorem of parallel axis. Please take it down. This is the expression for theorem of parallel axis. IZZ is, and all these ZZ and GG is with reference to the diagram, obviously, guys. IZZ, and how are IZZ and GG connected? They are parallel to each other. GG is passing through the geometric center. ZZ is not passing through the geometric center, right? So IZZ is equal to IGG plus the area into square of perpendicular distance between the parallel axes. So this is the expression for theorem of parallel axes. When I express this in words, it becomes the so-called definition of theorem of parallel axes. This question can come in theory also, describe or explain theorem of parallel axis. So you can take an example like this, explain it, and then you can so-called define it by saying, as per theorem of parallel axis, moment of inertia about any given axis is the sum of MOI about a parallel axis drawn through the geometric center, parallel axis through the geometric center. And so why and? Because we are saying sum of what? One is the MOI about a parallel axis through the GC, and what? And the product of area with square of perpendicular distance between the axes, between the two axes. Guys, I've done nothing. I've just given words to this expression. That's all. You can give your own words, no issues, as long as technically you don't alter the meaning of the thing. So, is the theorem of parallel axis clear to everybody? Please have a good look at it. You can, whatever you want to take down, you can take down. Theorem of parallel axis, as per theorem of parallel axis, the moment of inertia about any axis is equal to sum of the moment of inertia about a parallel axis through the geometric center and the product of the area with the square of the perpendicular distance between the two axes. Okay, guys, this we'll be extensively using. Remember that between these two, if you see, it is IGG plus AD square. Please remember that. Don't make it IGG is equal to IZZ plus AD square. No, it is IZZ is equal to IGG plus AD square. Am I clear, guys? Theorem of parallel axis is clear. Anybody has any questions on this, beta?
Yes, sir. No, sir.
No, okay, very good. So we come to end of this small presentation, and now we'll go on to the first application. Okay, do you want a 3 to 5 minutes break, or shall I start? I'm okay to start. I have no issues.
Start, sir. Start.
Start. Okay, very good. No problem. Good. Yellow. Okay. Guys, the first application of moment of inertia. So whatever we have learned, the formulae, they will be reinforced through use, including the theorem of parallel axis. Okay, beta. But before we start doing that, we will revisit. Somebody was asking me yesterday when we had the orientation connect, would the basics be covered? So I'm taking back you to chapter 2 of Captain Subramaniam Stability 1, pressure and thrust. Okay. Now, pressure in ship stability, forget about in physics, it is H rho G, it's Newton per meter square and all that. I limit myself to ship stability. In ship stability, the pressure is at any point below the liquid level is equal to the depth of the point below the liquid level multiplied by the density of the liquid. Am I correct, beta? Depth into density. And the units of pressure in ship stability we take as tons per meter square. Am I right? Correct, Pate? So please don't forget this. I'll show it on the screen also. Pressure at any point is the force per unit area, with SI units being Newton per meter square. As regards ship stability, we limit our scope to pressure exerted by a column of liquid at any point below its surface. The pressure due to a column of a liquid at any point below the surface of should be equal to, technically should be equal to, depth of the point multiplied by density multiplied by acceleration due to gravity, h rho g. However, in ship stability, since my ship is always on the surface of the earth and g remains practically constant, only to keep our calculation simple, g has just been kept aside for the sake of convenience. Okay, I have not changed the meaning of pressure. It's only g has been kept aside for the sake of convenience. Okay, is intentionally left out of the calculations for the sake of convenience. And therefore, in ship stability, most often we will say pressure is equal to depth of the point below the liquid surface in meters multiplied by the density in tons per cubic meter, and that will give us the pressure in tons per meter square. Any questions on this slide, guys? Or please don't forget this. When need arises, we'll have to use it.
Sir, this depth will be center of gravity of the liquid surface, no, sir?
No, we are talking of a pressure at a point. Pressure is can be at any point, na beta. Pressure, or whatever is the immersed area, the pressure at different points will be different, right?
I got it, sir. Got it, sir.
Pressure at different points will be different. अभी वो आएगा जो तुम कह रहे हो thrust के लिए, ठीक है? Okay, any questions on pressure, guys? None. Okay. The second term you learned there was thrust. Thrust is the force exerted on a surface. As regards ship stability, we limit our scope to thrust, that is force exerted by the liquid on an immersed surface. Thrust on an immersed surface is obtained by multiplying the pressure at the GC. This is what you're trying to say, beta, multiplied by with the area. So this is the thrust. Pressure at the geometric center of the immersed area. Please pay attention to the word immersed area. Whose geometric center? Geometric center of the immersed area. And multiplied by the immersed area will give you the thrust. What is the pressure at the geometric center? Pressure of the geometric center will be the depth of the GC and multiplied by density. So this is the pressure. This much is actually this part of the expression. And this is the immersed area. And so thrust will be in tons. Any questions on this slide, guys? Please don't forget it. Don't forget the word immersed. Any questions on pressure and thrust, guys? If anybody has anything in mind to basically seek clarification about. Done? Good.
Okay.
Good. Now we come to the first application of moment of inertia. That is center of pressure. We'll call it as COP. Okay. What is it, beta? See, weight is a force. It can be assumed to be acting through the center of that force called as center of gravity. Buoyancy is a force. It can be assumed to be acting through its center called as center of buoyancy. Correct? Likewise, we just said thrust is a force. Acting on what? Acting on a certain area. Thrust is a force acting on the immersed area. So if thrust is a force, weight was a force, buoyancy was a force, if weight and buoyancy can be expressed to be acting through their respective centers, then likewise, for the purpose of if full thrust is to be taken into account and somebody has to say which is the point through which entire thrust can be assumed to be acting through, that point is called as the COP or center of pressure. Clear, guys? It is the point through which the entire thrust can be assumed to be acting through. So thrust is the force exerted by the liquid on the immersed surface. We just said a while back. If the thrust exerted on a surface is to be considered as one entity, one force, it can be assumed as one force acting through the center of the force called as COP. So COP, it's called center of pressure, but it's actually the center of force of thrust. It's not the center where the pressure can be acting. COP, its analogy with other centers of forces like COG and COB, I just told you. So you can connect with that better now. Now, to get the COP, there is a formula. The derivation of the formula is not part of our syllabus. It's given in Derrits if anybody wants to look at it at a later time. Ship stability by Derrits has the derivation for formula for COP, just for your information in case you want to, at a later stage, want to have it. What you need to do now is just learn the formula. What is the formula? COPLL is equal to ILL upon area into DLL. This is LL is in subscript beta. Okay. Now, please remember in this. So, what is this formula? This formula is the COPLL is equal to ILL upon area into DLL. Now, what does this COPLL means? This means distance of COP from liquid level. LL is liquid level. So this formula will give you the distance always from liquid level, nowhere else. If the question wants answer not from liquid level, but from top of the bulkhead, from bottom of the bulkhead, you'll have to do the adjustment at the end. The formula cannot be modified to give you distance from base or distance from bulkhead top. The formula will always give you distance of the COP from liquid level. Is that clear, beta? Clear, guys?
Yes, sir. Yes, sir.
And
Yes,
what
sir.
is the formula? ILL. Now understand what is ILL. This is the moment of inertia. When I said moment of inertia, of what? Of immersed area. Then another thing I said was about which axis? About LL. Liquid level. So ILL is the moment of inertia of the immersed area about liquid level. So now you know which area. You'll have to identify the immersed area. You'll have to identify the liquid level. And then you'll have to find the moment of inertia of the immersed area about that axis. What is A? This is immersed area. What is DLL? This is the distance of GC of immersed area from liquid level. This is the distance of the GC of the So आपको क्या करना है? In every question, what will you be required to do? Draw the diagram, identify the immersed area, identify its geometric center, identify the liquid level, get the area of the geometric center, get the distance of its GC from the liquid level, and get the moment of inertia of the immersed area about liquid level. Once you get these three things, put them in this formula, you'll get the distance of the COP from liquid level. Is the formula clear to everybody, beta? Or any clarifications required?
Can you please repeat the last line, sir?
Which one, beta? Say again. Which one you want me to
Sir,
repeat?
Sir, distance of the, how we will get the distance of the liquid level, sir?
We will see in the question, but you need to get these three things to close the question. Correct, beta?
Okay, sir. And sir, the area will be the same, just a triangle.
Immersed area will be immersed area, beta. That's what I said. You
Immersed.
identify the immersed area. Correct? Once you identify the immersed area, then you will be able to identify its geometric center. You'll be able to identify liquid level. You will be then able to get the moment of inertia. So what will be your job in each question? You'll have to draw you'll have to draw appropriate diagram, because diagram will be the key to the questions. It is the diagram which is going to lead you to solution. Is that clear, bete? ठीक है बच्चों? Don't worry, don't worry. Once I start doing the questions, I'll ask you, what's your name, beta? I'll ask you the questions then. Vipul, don't worry. I'll ask you the question in the next question itself. Guys, is the each constituent of the formula is clear to you? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir. Yeah. Now we'll take the questions. We'll start with the simple ones and we'll go to the difficult ones. Now, first one is transverse bulkhead of a tank is 10 meters wide. Transverse bulkhead. Okay, it's a rectangular bulkhead. The shape is somewhere I have missed out in writing, I think. It's a rectangular transverse bulkhead of a tank. So please, I stand corrected. So it's the shape has to be mentioned. It's a rectangular transverse bulkhead of a tank, 10 meters wide and 8 meters high. Find the thrust on the bulkhead and the distance of the COP from base of the bulkhead if the tank contains seawater to a head of 3 meters and the density of the water is 1.010. Now, I will be talking to you, but I always tell people you talk to yourself when you solve and talk exactly the way I'm talking to you. If you learn this practice, you will never get confused. So pay attention to what I'm telling you. And in fact, you should be talking that to yourself when you solve. First, I draw the diagram. And if anybody has any questions, I'll come back to you. Don't worry. So first step is I draw the diagram. It's 10 meters wide, 8 meters high. It contains seawater to a head of 3 meters. Head of 3 meters means the water is into the sounding pipes and air pipes 3 meters above the top of the tank. So that is the liquid level. This is 3 meters of head. That means the water is in the sounding and air pipes. It is 3 meters above the top of the tank. That is what is meant by 3 meters of head. Okay. So once the water is in the air pipe, sounding pipe, then that means the tank is full. If the tank is full, this entire area is immersed area. I have identified the immersed area. Why? Because if the tank is full, entire area is the immersed area. So I have identified the immersed area. Then I'm looking at the shape of the immersed area. It's a rectangle. We just learned what is the geometric center. It is the intersection of the diagonal. So here is the geometric center of the rectangle. What is the distance of this geometric center, DLL, distance of the geometric center from liquid level? This is 1/4 of the half of the height, 4 meters plus 3 meters, that is 7 meters. I'll come to you for doubts, don't worry. Okay, so I have DLL, I know the area will be length into breadth. Now I need to get the moment of inertia of the immersed area about liquid level. So first we have to get the thrust. So let's get the thrust first. Thrust. I am not going to fill up half the page in calculating pressure separately, thrust separately. We don't have that much of time. I said thrust is the pressure at the GC, pressure at G. Pressure at G will be DLL into the density of water. This is the pressure at G multiplied by the area 10 into 8. This will be the thrust in tons. Whatever it comes, I'm going to leave it as it is. Second is I have to calculate the COP, but he wants COP from where? He wants from base, but my formula does not give me from base. My formula will give me from wherever it is giving. That's all. So my formula is going to give me the distance of the COP from liquid level. The formula is ILL upon A into DLL. A I have, DLL I have. I don't have ILL. I look at the diagram. Now, is LL a standard axis for rectangle? Now, standard axis for rectangle, what we did today was they were both passing through G. Unfortunately, LL does not pass through G. Therefore, I cannot use those formulae directly what we learned today. What now I explore is the use of theorem of parallel axis. What do I do? Through the geometric center, I draw an axis parallel to LL. I call it as GG. And now, yes, I can get ILL through theorem of parallel axis. I simply my formula, this becomes, I apply theorem of parallel axis for ILL, which will be equal to IGG plus A into D. Now, what is the D between the two parallel axes? That is DLL, DLL square divided by A into DLL. Now, is GG a standard axis? Yes, GG is a standard axis for the rectangle. Which side is it cutting? It's cutting 8 meters. So it will be 10 into 8 cube upon 12 IGG. It plus area is 10 into 8. DLL is 7 divided by area of 80 into DLL of 7. This will give me COP/LL in meters. Okay, but I want to give COP from base. Now COP from base, if you see, I have got from here, that is the liquid level. I want from here the base. The total sounding is 8 plus 3, 11 meters. So 11 meters of sounding minus COP/LL will give me the answer from base. Now, I'm not worried about the values. I'm now going to check with you, is the entire process clearly understood by each one of you the way I spoke it out, Vita? Tell me now, if anybody has any doubts, now speak up.
Sir, could you just recap it once again?
No, I will not recap it once again. You tell me, where are you getting stuck? In which constituent are you getting stuck? That will be the better way to learn, beta. Is the area calculation giving you problem? Is DLL giving you problem? What, or is the diagram giving you problem? Tell me, what is the problem area, beta? Identify your problem area.
The area part, sir. The area part.
What is the immersed area? If the tank is full, then entire bulkhead is immersed, yes or no?
Yes, sir.
So immersed area will be the full bulkhead, yes or no, beta?
Yes, sir. And okay. And we have taken the height of the liquid that for the upper axis.
No. Firstly, is the area part clear, or it is continuation of area concern?
No,
Sir.
that's okay.
Let him finish, beta. First, let me finish with him,
Okay.
then I'll come to you. Continue, beta.
Okay, we've taken since it has a head of 3 meters, so we take the upper axis, the liquid level.
I'll ask you simple questions. Is the water in the sounding pipe and air pipe part of the tank? Yes or no? Is
Yes,
that
sir.
water connected to the tank?
Yes, sir. Yes, sir.
So then that is, if it belongs to the tank, then the liquid level of the tank is where the level is, right?
Yes, sir. Yes, sir.
Does that answer your question?
Yes, sir.
Okay. Anything else, beta, before I go to the other person?
No, it's okay. It's okay, sir.
No. So see, what I'm saying is, don't doubt yourself to that extent. Recap everything. Don't doubt that. You need to just see where are you getting stuck. Okay, beta?
Yes, sir. I got
Otherwise,
it.
if I do a recap, it will be like a parrot. I'll repeat again. It's not going to serve any purpose.
Yes, sir.
If I address your specific doubt, then I'll change my version. I'll try to give you more examples and explain. So let's be specific about our doubts. That will be the better way to learn. Yeah, somebody else who was asking a doubt. Beta, go ahead.
Sir, why are not we using the, we are editing the area of pipe?
Bete, this is the 2D diagram. in a tank which I am drawing now, एक tank, recall तुम जहाज पे काम करके आए हो, अगर tank ऐसे है, if the tank is like this, the sounding pipe is not part of the bulkhead. Sounding pipe, air pipes are like this. They are clear of the bulkhead, correct? Can you see this?
Yes, sir. Yes, sir.
This diagram that I have drawn, 3D diagram
Yes,
now?
yes. Yes, sir.
Correct. So sounding pipe is a separate fixture of the tank. It's not part of the bulkhead in question. It is because it's a 2D diagram, it is giving you a false impression as if it's connected to the bulkhead. Understood?
Okay. But liquid in the pipe will also be exerting some thrust or pressure on the.
No. But that will exert thrust on the sounding pipe, no, not on the bulkhead.
Okay.
He's talking about COP of the bulkhead, correct?
Yes, yes.
Or the thrust on the bulkhead, correct, bete?
Yes, yes.
Whatever thrust is coming on the sounding pipe or air pipe, that is when we talk about that, we talk about that. That does not change the. What is going to change the thrust on the bulkhead is either the immersed area of the bulkhead changes or
Yes.
the depth of the geometric center changes.
Yes.
Or the density of the liquid changes. Correct?
Yes.
See that this second diagram which I made now, is it clear? This is the sounding pipe. So here is the bulkhead. Let's say this is the bulkhead you are talking about. This is the bulkhead. Sounding pipe is not part of the bulkhead.
Yes, yes.
Or air pipe is not part of the bulkhead. Any more questions on this, guys? These are the answers.
Sir,
you can close out these answer, calculate and close out the question, or you can calculate by yourself afterwards also. But if you want to close it now, you can close it now.
Sir, one question regarding the DLL. So DLL, why are we including the sounding pipe then? If we are not including this
No. I just
area.
no. There are two. You're mixing up two issues. Why I said sounding pipe area is not to be included is because the question says the thrust on the bulkhead and the area, surface area of the sounding pipe is not part of the bulkhead. That was my question. Answer, correct? Do you agree with that?
Yes, sir.
Okay. Depth of the geometric center from the liquid level in the compartment. I answered that a while back. Is the air pipe, is the water in the air pipe, does this belong to the tank? Yes or no?
Yes, sir. To the tank, yes.
If the liquid belongs to the tank, then wherever is the surface of the liquid, that is the surface of the liquid level.
Okay, sir.
Correct? Yes or no?
Yes, sir.
So it does not get added to area, but it is part of the liquid. So liquid level will be where the liquid ends, right? Correct,
right.
bete?
Right, sir.
That is why when you do the pressure testing of your bulkheads and everything, you fill up water into the air pipes up to the top because that exerts head on the bulkheads, right?
Yes, sir.
Okay. Fine. Any more questions on this
Yes,
one,
sir.
guys? First question is done.
Yes, sir. Sir,
Yes, sir.
one question.
Yeah.
Sir, can you explain one more time moment of inertia at liquid level, sir? ILL.
So
Which we have elaborated.
no, so first I said, I checked, is ILL a standard axis? We did two formulae for moment of inertia for rectangle. Yes or no?
Yes, sir. Yes, sir.
But both those axes were passing through the geometric center, right?
Yes, sir.
But ILL is this LL is not passing through the geometric center G. Yes or no?
Yes. Yes, sir. Yes, sir.
So those two formulae cannot directly be used for LL, correct?
Yes, sir.
Then what did we do? Then we used the theorem of parallel axis, which we did the last.
Okay, sir. Okay.
So what did we do? We drew a parallel axis through G and we called it as the small gg.
Yes, sir. Yes, sir.
Correct? Now what
Yes,
is
sir.
the perpendicular distance between LL and GG? It's same as DLL. Yes or no?
Yes, sir. Yes, sir.
So then this is the theorem of, this is basically by theorem of parallel axis, right?
Understood, sir. Understood. Thanks a lot, sir.
Okay.
Understood.
Any more questions, guys? See, if basics are sorted out in a simplified question, then rest would be easier to build upon. So if everybody is happy, can we go to the next question then? Unless somebody else.
Yes, sir.
So guys, what are the issues? Proper diagram, Identification of liquid level, identification of immersed area, identifying the geometric center of the immersed area, getting DLL, getting the area, and then exploring whether it is directly or through theorem of parallel axis, whichever way, you can get the ILL, and that closes the question. Okay.
हेलो सर एक
Yeah,
क्वेश्चन
tell me.
सर ये जो लिखा था ना इसमें हेड ऑफ 3 meters, इसको थोड़ा
Yes.
डिकोड करने में
कुछ
हमने
नहीं है बेटा.
मैंने
Head of 3 meters, your head of your body is head is above your body, yes or no?
वो ठीक है सर, लेकिन जब इसमें
Head,
eyelids
no, head is no. Arey, I'm decoding it. Don't worry. Head is above your body, correct? It's placed on the body. So head of the water is placed on the top of the tank. Does that answer your question?
Okay, take it.
No, does that answer?
Yes, sir.
Okay, so head means it is above the top of the tank, bete. Head. Okay. Yeah, fine. No. This is how I'll respond. Don't go on defensive, man.
Nice.
This is the way you'll get the response, and this is the way you'll learn. This is the way you'll learn. Don't worry. Okay. Okay. Can we go to the next question? Tell me.
Sir, if the tank is not full,
don't talk
then
about
also we will take the head for the...
No. Let's not add riders. Let's limit our discussion to this question, beta. Maybe your riders will be automatically addressed. Why speculate on question number one itself?
Okay.
Is the very basic concept in place, beta? Correct? Once I have done the questions, you still have any doubts? I'll take your riders. Don't worry.
No, sir.
But maybe the riders will be automatically addressed as we go forward. No? Okay. Chalo, we go to the next one, guys. Okay, let me take this one also, and then maybe I'll seek your help. A vertical bulkhead is in the form of a triangle, apex downwards. Read this carefully. Sometimes the apex is given upwards also. So be careful, guys. Okay. The bulkhead is 9 meters broad at top and 12 meters deep. The tank contains seawater to a sounding of 8 meters. Guys, can you please make this bulkhead and draw the liquid level and shade the immersed area? Then I'll draw. I'll take 10 seconds. I'll lag behind by 10 seconds intentionally. A vertical bulkhead is in the form of a triangle, apex down, 9 meters broad on top, 12 meters deep, contains seawater to a sounding of 8 meters, shade the immersed area. So first do the diagram part. Those who draw it correctly, good, congratulations. Those who make mistakes, it will be a good learning out of it. Don't worry. Okay. I'm quietly drawing it. If you don't agree with me, I'll not explain anything. I'll explain only if there are questions on that. Is that correct, guys?
Yes, sir.
Yes, sir.
Anybody who has any doubts as far as the thing is concerned, right? Anybody has any doubts on the diagram, beta? Any clarification required? Let's deal with step by step. Okay. Now, beta, if I have to get the immersed area, which is triangular in shape, I'm marking it in red here. I need to know its base and height. Okay, height I know 8 meters. I need to calculate this base x. Yes or no, beta? Correct, guys? Yes or no?
Yes, sir.
How do I get x? I have two triangles. One big triangle, other is small triangle. They are similar triangles. Why they are similar? Because this angle is common to them. This angle is equal to this one. This one is equal to this one. They are corresponding angles of parallel lines. So the triangles are similar by A property, angle property. Whenever the triangles are similar, guys, the ratio of the corresponding sides, there's important word corresponding. The ratio of the corresponding sides and the corresponding heights is same. So ratio of corresponding sides, corresponding heights, the ratio is same. That means side one of one triangle divided by side one of the other triangle will be equal to side two of the first triangle divided by side two of the thing, and likewise it continues with the heights also. So by similar triangles, we'll not give much explanation in our solutions, but if anybody has any problems, you please raise that once I write here. By similar triangles, what is the side corresponding to x? It is 9 meters, correct guys? Am I right?
Yes, sir.
So ratio of this side, this one and this one is x by 9, correct bete?
Yes.
Correct? What is corresponding to this height of 8 meters? It is height of 12 meters, correct? Yes or no?
Yes, sir.
On top, I have written the side of the smaller triangle. So I'll write the height of the smaller triangle on top. It is 8 by 12. And this will give us the value of x as how much?
6.
6 meters. Okay, now anybody has any questions on getting x, please thresh it out here, because it should not become the problem for COP. Because if you can't get this, you can't do the question. That's pure geometry part. So if anybody needs any more clarification, please let me know. Clear beta? Corresponding sides ke ratio. Is that clear to everybody? Can I proceed, continue further then? If everybody is happy with x equal to 6?
Yes, sir.
Yes, sir.
Guys,
Yes,
if you
sir.
have anything, just feel free to clear it. Don't just get bogged down by the class saying yes, yes, yes. Okay. So once x is done, it's good for me. Guys, where
Sir,
will be
this-
the geometry? Yeah, tell me. Say again.
So the value of x, that x upon 9 is equal to 8 upon 12. There is having some doubt.
What is the doubt? Tell me, beta. What did I just, can you repeat the statement I made before I wrote this?
This we were talking about the equal axis, sir.
Eh?
Corresponding equal axis.
Corresponding equal axis. No, I didn't say that. You're not even repeating my statement, beta. What is the property of similar triangles that I just said? What was the statement I made? Because if you make the statement correctly, probably you'll get your answer. That's what I'm saying. Anybody in the class?
Ratio of similar triangles is equal.
No. You made an attempt, good, but again you're eating away the vital words.
Ratio of
In similar triangles, the ratio of the corresponding sides, ratio of the corresponding sides and ratio of the corresponding heights, they are same, constant. Is that clear, bete? Somebody who started with a doubt. Did you hear this statement, beta?
Yes, I got it. Thank you, sir.
And then I asked you which is the corresponding side of to the x of small triangle, which is the corresponding side in the bigger triangle. Which is the corresponding side to x, beta? Can you tell me? Bol bhai, which is the side corresponding to x, beta?
9.
9. अरे यार
9 meters.
तुम डाउट पूछते फिर गायब हो जाते हो, ऐसे मत करो भाई. Don't do that. Okay. So that is x is equal to 6 meters. Okay. Now we are good to get the immersed area. So immersed area will be equal to, though I don't have to calculate, but I'm just finishing off one by one. Half base into height. That is the immersed area. And that is 24 square meters. Am I right, guys?
Yes, sir.
Where will be the geometric center of this triangle? It is going to be the intersection of medians. Correct, beta? Here. Correct? This will be the G.
Yes, sir.
I'm talking of G of the immersed area. I'm not talking of G of the full bulkhead, guys. Can you tell me what will be the distance of this G from the liquid level. I'm not interested from top. I'm only talking about DLL. What will be DLL?
The 1/3H.
Why? So what is H? Look at the diagram.
H is
Tell me.
8
8.
meters.
He says 8/3 meters. Does everybody agree?
Okay, no, so 2/3 of the 8.
Yes, sir.
Yes, sir.
No, beta, 2/3 from the vertex, beta. I told you that time also, be careful. When I was explaining, I warned you then also. It's 1/3 from base and 2/3 from vertex. So X is the base of the chota triangle. It's not the vertex. Vertex is this one. Yes or no?
Yes, yes, sir.
This is the vertex, beta. Right?
Yes, sir.
So does that answer the question? DLL is 8/3. So DLL is 8/3. Guys, look at the formula for triangle. So first, let's get the thrust also. Okay, let's get the thrust first. So thrust will be equal to pressure at the GC, that is depth 8/3, density seawater into area 24. So many tons is the thrust. The answer is 65.6 tons. Correct, beta? Yes or no? Correct, guys? Please satisfy yourself with the thrust first.
Yes, sir.
Second is he wants the COP from the bottom of the bulkhead, but we will not get from the bottom. Our formula will give you from liquid level only. It shall be equal to ILL upon immersed area into DLL. DLL and A are already in place. Look at that. Go to that sheet for triangle. Is LL a standard axis in those formulae? Guys, tell me. Go to the PDF I sent you yesterday. Go to the triangle and see,
No,
is
sir.
LL a standard axis? Is the formula about
Yes.
LL given in the question in the sheet? Yes or no?
No, sir.
Yes, sir. Yes, sir.
What is
The
the
YY.
formula?
Yes, sir. Yes, sir. I
What
accept.
is the formula?
BD cube
BD
upon
cube
36.
BD cube by 12. 36 will be about GG. BD cube by 36 would be about GG, right, bete?
Yes, yes, sir.
The immersed area is like this, guys. This is 6 meters. This is 8 meters. This is the triangle I'm making here. And if this is the liquid level, then it is about the base. Yes or no? Yes or no, guys?
Yes, sir. Yes, sir.
If you use GG, you'll have to use theorem of parallel axis. You'll eat more time. You'll get the answer through that also, because that formula is derived through this use of parallel axis only. But what I'm saying is, if you know that second formula, you can cut short straight away. Yes or no, beta?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
1 second. No. Yes, sir. Yes, sir. Adi Janta, half the guys are lost about it again. They are getting confused somewhere. Guys, if you see this one, in this one, what is YY? Is it not about the base? And what is the formula about YY?
BDQ 12.
In our case, the triangle is like this. How does it change? Does it change the things?
No, sir.
Our triangle
No,
is like
sir.
this.
Yes.
The base will still remain base. Yes or no?
Oh, yes, yes, sir.
Yes, sir.
Correct? So base will still remain base. I can do it by theorem of parallel axis also if you want. That's not an issue, but it will be unnecessarily waste of time. So ILL will be equal to BD cube upon 12. What is base? Tell me what is base in our question. Value of base? 6. What is D?
8.
8/3.
8 cube. No, D. Not DLL. Depth, capital D, beta. BD cube by 12.
8 cube. 8 cube.
Yeah, this is ILL. Have you understood? This is ILL. Correct, beta? Divided by area of 24 square meters into DLL of 8 by 3. And this will give you COPLL. This will give you answer of 4 meters here from liquid level. Calculate and see. If you have not satisfied, let me know. I'll try and clear the board and do it again. And then COP from base will be equal to sounding minus COPLL, which is 8 minus 4. Again, the answer is 4 meters. But this 4 came from liquid level, not from base. Incidentally, both are same. It should not happen that you get again confused. The
Sir, one
formula
thing,
gave
sir.
you from liquid level. Yes, tell me.
Sir, I took 2 by 3 calculating. I did from the base only, sir. 2 by 3 से कराया, so that is wrong. I have to calculate.
What have you done by 2 by 3?
मैंने सर जैसे इसमें आपने थर्स्ट और ये COP from the top से निकाल के फिर बाद में subtract कराया ना सर. In thrust also I took 2 by 3 instead of 1 by 3.
What do you mean by 2 by 3? What do you mean you took 2 by 3? What is 2 by 3 from liquid level?
क्योंकि इसमें सर bottom से calculate करना था ना, so from the starting I took.
And what did I tell you when? No, firstly, thrust has nothing to do with bottom or top.
Okay.
How can you calculate thrust from bottom? Thrust has nothing to do with the bottom. Were you not there when I was explaining beta COP formula? Were you not in the class then?
I was there, sir.
I don't think you were there because I told you 4 times that the formula will always give from liquid level.
Okay.
Was this statement not registered?
Got it, sir. Got it.
I doubt you are in the class because if you make such mistakes, despite 4 times repeating and emphasizing upon it, that formula will not give you from wherever you want. Formula will give you from wherever it has to give. And then again, you're saying I calculated from bottom. The previous question was also from bottom. No, why didn't you do it that way there? Did you do the same way in the last question also?
Negative, sir.
So then what has happened suddenly from the... See, either you have been in between disconnected from the class, you suddenly have come into the class and now you're confused and going all over the place. And sitting at a distance from you, I can tell you, you have not been in the class through and through. You have been missing the class. And suddenly you're connected and now you're suddenly trying to find your bearings.
Sir, Imran here, sir. I have one doubt, sir.
Yeah, tell me.
सर ये जो हम ट्रायंगल में अभी हमने जो थ्योरम ऑफ पैरेलल एक्सिस नहीं लगाया है जो हम
बेटा theorem of parallel, that formula which we have derived, let me just take you to the previous sheet if it is clear. Let me take you to the next one here. This theorem of parallel axis is what has been used. I'll tell you. This is GG. Okay. This is B. This is D. Okay. And we are trying to get about YY. Okay. This distance will be D by 3. I'm sure you agree with this, Imran, yes or no?
Yes, correct, sir.
Okay. So what IYY by theorem of parallel, this formula BD cube by 12 has been obtained by theorem of parallel axis only. I'm saying if you learn it, you can skip that step.
No, sir, I know that doubt. My doubt is clear for that. I'm just asking कि box shape के लिए हमने theorem of parallel axis use किया था और इसके लिए हमने डायरेक्टली जो है वो ले लिया क्योंकि हमें उस एरिया का चाहिए था G पॉइंट का.
Because
मुझे ये कैसे पता चलेगा कि मुझे मैं ये कैसे करके जज करूंगा सर कि मुझे जैसे बॉक्स शेप में हमने वो फॉर्मूला लिया था ना ILL into AD square upon ILL plus AD square. तो ये सर जो है ये हम कैसे करके जज कर सकते हैं?
No, but what I'm saying is you can get firstly, if you have a doubt, you can in that very question you can use theorem of parallel axis. Okay, first and foremost, if there is any doubt in your mind that the formula I'm using is that correct or not, because doubts can still come anytime in your mind, right? If you ever get a doubt whether should you use this formula or not, you can abandon that formula and go from the basics of theorem of parallel axis. Okay, beta?
Okay.
Okay. Number 2, coming to answering your question as to how can you identify. How can you identify is by basically seeing that the formula that you know, does your liquid level fit into any of those given cases? Yes or no?
Yes, sir.
Now, in this case, guys, can I clear this and explain to him this question? Is the working part clear? The calculation part?
Yes, sir. Yes,
okay,
sir.
I'll clear this and then probably explain to him the issue. I'll clear this thing. See, Imran, it's very simple. Nothing to worry about. See, it was like this. If you want, I can do it by theorem of parallel axis also now. This was, our case was 6 meters. This came as 8. This was 9 and this was 12. This is what we are. And this was the area of interest now. The area above the liquid level is of no interest to us. Correct, Imran?
Correct, sir.
Okay. Now, you see this diagram without anything cluttering it. You want ILL of the shaded area. Yes or no?
Correct, sir.
Correct. What is the shape of the shaded area? It's a triangle.
Triangle.
Is liquid level coinciding with the base? Yes. So if I want, I can use that formula. Correct, Peter?
Yes, sir.
If you don't want to use it, let me also do it by theorem of parallel axis. You'll get the same answer. GG. This is DLL 8 by 3. No, yeah, 8 by 3. Correct. So you see, COPLL will be equal to ILL. This is upon A into DLL. ILL will be equal to IGG plus area into DLL square upon A into DLL. IGG will be BD cube upon 36. B is 6. D is cube upon 36. This is IGG. Do you agree with it, Imran?
Yes, sir.
Area is 24. 24, okay. 24 into DLL is 8 by 3 whole square divided by area of 24 into 8 by 3. If you solve this, it will again come 4 meters better. You can solve and check. So if you have a doubt, firstly, there should not be doubt. But if you have a doubt, you can go back to theorem of parallel axis, go to basics, no problem. That was just to save time, nothing else.
Okay, sir.
Understood?
Copied, sir.
Yeah. So if you are clear that you can take a shortcut, take a shortcut. If you think you are doubtful whether to take a shortcut or does the shortcut apply or not, don't worry, go to the basics. It will take another couple of minutes. That's all it will do. Nothing else. Okay, beta?
Okay, sir.
Okay. Guys, so far so good. COP?
Yes, sir. Sir, if possible, 5-7 minute का break दीजिए.
Okay, 5-7 minutes. Okay, it's 10. 5 minutes is good enough. 11:15. Can we start?
Yes, sir. Yes, sir.
Or 11:20. I'm okay with both the timings. No issues. What time, guys?
5 minutes.
5 minutes. Okay. Okay. Fine. Let's connect at 11:15. We'll resume.
Okay, sir.
Okay. I'll share my screen. I'm connected because I'll clear a mail in the meantime. No problem. Okay.